So, okay, so like we were saying, conditional probability is the probability of an event happening given something else has already happened. So, when we're doing these, notice they have this big fancy formula over here, P of A and B and divided by B. Just, no, bad. Why? We're not making this complicated. We're going to make this a little bit simpler than that. So here's what we're going to do. I look at this and it says, okay, Naomi's playing a game with this spinner that's over here. What's the probability that the spinner lands on 7, given that Naomi has spun a number greater than 5? Okay, here's what we're going to do instead of all the fancy stuff. We're going to take whatever the end result is that we want to happen, our success, and we're going to divide it by what comes after the word given. We're going to do this instead of, this is our new little formula for this. So here's how this is going to work. When I'm looking at these problems, I find the word given, I underline it, circle it, do something with it. So I look afterwards and I go, okay, here's how this goes. Naomi has spun a number greater than 5. Okay, how many numbers are on that spinner are greater than 5?
That aren't 5?
No, greater than 5. 3 of them, 6, 7, and 8. Okay, that's my denominator. So then my end result is, what did I want to happen? So let's see. So we'll write these down. So 6, 7, and 8 were the numbers I was looking at. What do I want to happen? End result, get a 7. How many chances do I have to get a 7 on this spinner? 1. Probability is 1/3. I'm done. That's much easier than trying to figure out what's the probability of getting a 7, what's the probability of getting greater than 5, let's multiply them together. We don't want to get into all of that. We want to keep this simple and straightforward. So whatever's given goes on the bottom. Whatever I want to happen based on that goes on the top. So, because see how their fancy work? They got the same answer we did, but ours is a little easier. Now, next, okay, cards are drawn from a standard deck of 52 cards. Find each probability. To assist some of you that do not have a lot of card playing background, I put a little chart up over on that side wall, kind of describing all of the different things that can happen when you're getting into card playing. Suits, values, colors, face cards, all that interesting stuff like that. And I currently have a little cheat sheet being taken care of down in the copy room, but it wasn't ready yet. So as soon as I get that, I will get that out to you too. So here's how this works. Again, find the word given. There it is. The card is a heart. That's my end result. That's what I want to happen. I want this card to be a heart. But given that the ace is drawn, whatever is after given is always going to be the number that I put in my denominator. So I say, okay, so an ace is drawn. That's my denominator. I'm not going to put a number yet because I want to understand where this all comes from. So if I draw an ace and I want the card to be a heart, my only success would be if I got the ace of hearts. Because I know it's going to be an ace, so it has to be one of 4. It can be the ace of hearts, the ace of diamonds, the ace of spades, or the ace of clubs. Because there's 4 of every card. But I only want the one that's a heart. Well, there's only one of those ace of hearts in the deck. And there's only 4 aces total in the deck. That's my probability. But it all bases off of what is given. I have to think about that part first. And again, for those of you that aren't familiar with cards, don't worry, they're not all cards. So you'll just have to kind of get used to it here a little bit with us. So again, there's my word given. Given that a club is drawn, okay? And again, on the homework, you won't have to do all these writing things, but I want you to be able to look back later and say, ooh, that's where those numbers are coming from. So I got a club in the bottom. So then here is what I want to happen at the end. I want to get the 6 of clubs. That's my goal. Well, in the deck, there's only one 6 of clubs. So That's 1. And a club is one of the 4 suits. So again, if that's not something you're familiar with, if you look over there, there's 13 of each suit. So there's 13 clubs. That's my chances of getting that. That's my conditional probability. So it's sort of like an if-then type statement. Okay. Given that a black card is drawn, okay, half of my deck is black because the clubs and spades are. So, but for now, I'm just going to write what I got here. So I want a black, given it's a black card, I want it to be a spade. Now, black cards, there's 13 clubs and 13 spades. So there's 26 black cards. But spades, there's 13 of them. Always reduce my fractions. 13 over 26 means I got about a 50-50 shot that if I get a black card for sure, that it's going to end up being a spade. But again, don't freak out if you're not a card person, because I've got all those card values put on the side, and I'll leave those there until we're done with these. But again, it just keeps going back to, there's the given. Roll is even. Okay, so I'm going to have even numbers on the bottom. On top, roll a 4. When I'm rolling a dice, there's one way to roll a 4. When I roll a dice, how many numbers are even? 3 of them. Because if I think about the numbers that I could roll, there's my 3 even numbers. 1 over 3. I'm good. So this kind of takes what we've been doing and stretches it a little bit. Okay, there's given. So I got less than 6. And up top, I've got that I roll 2. Now again, think about it for a second. Less than 6. Okay, so 5, 4, 3, 2, 1. I got 5 options that are less than 6. Getting a 2 is one of those options. Okay. Now, some of you may be starting to think, is it going to be 1 over something every single time? No, because we're going to start getting into some multiple things going on. But it just kind of happens to be that way so far. So last one here, given. Given that I roll 3 or 4, and I want to get an even number. Well, rolling 3 or 4, there's only 2 choices. How many of those 2 choices are even? None of them, one of them, both of them, one of them, just the 4. So I get that, and it's 1/2. Now, again, that's more of a basic, straightforward one where there's one event going on, and you'd have one after the other, kind of one combined. However, sometimes this is going to stretch a little bit. So next, we get to this part that talks about what's called a contingency table. It gives you a breakdown of what everybody does and does not do in the different ages, or in this case, classes in high school or college, maybe, of what they're doing. So what you typically are going to do on this, and I made a mathematical boo-boo that we have to fix. That says 17, not 14. So this is 17. And this should say 2183, so we'll get that fixed. But we're going to see where that comes from. So what I can do typically when I get a chart or a table like this is I want to know what the totals are going sideways and up and down. So I'm going to go ahead and I'm going to add down for each of the classes, my freshmen, my sophomores, my juniors, and my seniors. And I'm also going to add horizontally to know how many people played lacrosse and how many people didn't. And what should happen if I did this right is that these 4 numbers should add up to 2183. And these 2 numbers, if I add them up, should equal 2183. And I'll help you out here. They do. But again, we're not using formulas. We're going to keep thinking the way that we have been on every problem that we've done so far. The key is still finding the word given. We still look at what's after that. Okay, so we're going to be looking at the juniors. That's my given. Probability that they play lacrosse, given they're a junior. So this would be a junior lacrosse player. That's what would go on the top of my fraction. So I start to look at my chart. I'm like, okay, I need to know the number of juniors, 544, okay. And I need to know the number of lacrosse players that are juniors. Plays lacrosse, junior. There's 34. Okay, so finally we got something that's not 1 over, right? So I look at this and I go, okay, so 34 divided by 544. I want my simplest fraction is 1 over 16. That's the answer, again, that they got using their fancy formula and doing all this other stuff that we just did by using a little common sense. And that's the way we're going to tackle this. And that's going to continue to be true on these contingency tables. I'm just going to move this up a bit. That'll still be there. Okay. Again, continue to look for the word given. Given, the person's in the bride's family. Okay, bride, the bride's fam here. We can start shortcutting a little bit. So look before that. A person can attend the wedding, given they're in the bride's family. So, bride's family and they attend. So whatever I'm doing up top takes this part into consideration. So I go, okay, bride's family. Oops, I haven't added this yet. Okay, there's 136 people in the bride's family. Find the probability that they can attend the wedding. Bride's family can attend. 104. And again, once you've got it, punch it in and get your simplest fractional answer. There's a 13 out of 17 possibility that if they're from the bride's family, they're going to be attending. So for any of these, given what? Given they're a senior. Well, what types of seniors am I looking for? Ooh, ones that play baseball. So I go, ooh, seniors. I got to add up my seniors here. So I've got 340 seniors, of which, how many seniors play baseball? 34. And I do a little math enter action. So it just ends up being 1 over 10. But again, it comes back to whatever's after given goes in the bottom. Whatever's before that takes this into consideration. Okay, I can't just use everybody that plays baseball. It wouldn't work. So I have to make that connection. Now, this one, this gets a little larger. And I apologize for my numbering because this goes with this. And I did the same thing on the worksheet, but we'll talk about that in a second here. So 4 businesses in town answered a questionnaire asking how many people pay for their purchases using cash, credit, or debit. Find each possibility. Okay, let's see how well I can keep this all on the screen here. Okay, a shopper uses a credit card given. Shopper's shopping at Jacob's Gas. Okay, so Jacob's Gas is my denominator. Numerator uses a credit card. So credit card at Jacob's Gas. Because again, what's after given always is part. It kind of narrows down my field a little bit. You're like, oh, we got to add these, don't we? Yeah. So I'll help a bit here. So 1140. I'll just give you all the totals in case we need them for different problems here. Square Scooch that just a little. And get my grand total going both ways here. So once I have all those numbers, that's going to help me when I'm getting into my denominators on these, because I will need those values, at least some of them, for when I'm calculating these. So I look and I go, okay, well, Jacob's Gas, there was 1,140 purchases. And how many of them at Jacob's Gas used a credit card? 456. So I'm like, okay. Two out of 5 would be using the credit card if we're just looking at Jacob's Gas. So you're like, okay, I see where you're heading with this, Harty. I don't think you need to go much crazier here. So one more. Shopper uses a debit given. They're shopping at Pet Town, so Pet Town's my denominator. Debit, but not just any debit, debit at Pet Town. So I go, all right, 147 people, purchases at Pet Town. 28 of them use the old debit card. And I get my fraction reduced as far as I can. Now, there's one twist to these, because I noticed it as I started to look through the worksheet that I switched up to today instead of going to the book assignment. And I noticed one change of a situation that I want to make sure you're aware of. So we're going to do one last example I make up down here at the bottom. We're going to go back to cards for a second here. Make myself a little room, keep that up there still. Okay, so one last note. If the word in the middle is then instead of given, we are going to multiply, not inside, oh, Harty, multiply instead of divide. It won't happen much, but when you go looking for that magic word in the middle for given and you don't find it and you see then instead, we're going to multiply whatever the values are together. So here's what something like that could look like. Let's say you get something like draw a heart from a deck of cards that is, then a diamond. Okay, my word changed up. It doesn't say given, it says then. So what do I do? Well, what we're going to do here is we're going to do the two things separately, and we're going to multiply them together. So when I look at this, when I say, okay, so first I want to draw a heart from the deck. So my probability would be drawing a heart from the whole deck. But when it says then, I'm going to be multiplying. I want to get a diamond. That is my success. But here's where I got to be careful. I'm picking from the whole deck -1. Because actually, I will have drawn a heart with my first card, and that card's still in my hand. So I'm not picking from the whole deck anymore because there's one card that's been taken out. So I go, okay, so hearts, there's 13 of them in the deck, and a whole deck is 52 cards. There's also 13 diamonds in the deck, but now it's the whole deck -1, minus the one I took here. So now there's only 51 cards in the deck. And I go ahead and I multiply across. And give a little math enter. and I get my probability for doing a heart then a diamond. But again, only if the word in the middle changes from given to then do you want to go this route. Otherwise, just keep doing the one fraction, the given part on the bottom, and that first part goes back on the top. So you'll be working on conditional probability practice AB. Got a key up front for you to be able to check out. See how this is going. Monday we'll play with experimental stuff a little bit. And then we'll be doing some review on Tuesday, and we're looking towards Wednesday. I'm just looking at park scheduling. Yes, we're looking at Wednesday for your quiz on this stuff. So